All right. Good evening, friends. Hope you're okay. Please confirm that you're able to see the screen. Please confirm that you're able to see the screen. So we are going to talk about measures of dispersion. And these include 6 major measures of dispersion. We have the range, the quartiles, the percentiles, the deciles, the variance, standard deviation. So here we have the 6 major measures of dispersion. The simplest measure of dispersion is the range. So we shall begin with this one here. And here we are saying that the range is the difference between the highest score and the lowest score, which are the extreme values, which we are referring to here as the extreme values of a distribution. Meaning that when you want to get the range, we shall get the highest score minus the lowest score. So if we try to paint a picture here, assuming that we have a distribution, if I say this is our example 1, and we have set A having maybe 75, 27, 12, 8, let's say we have 62, we have 10 and 5. If we want to determine the range, we shall say that the range is equal to highest score minus the lowest score. So what is our highest score here? What do you think is our highest score? In the chart, anybody? Highest score is 75 minus the lowest score, which is, what is our lowest score? So the highest here is a 75. Yes. The lowest is 5. This one here. Okay. So minus 5. So that gives us a range of 70. That gives us the range of 70. So we would simply give that as the measure of dispersion for that particular distribution. Now, one of the weaknesses of the range, if I can just go to this other side, is that the range does not consider the values in between the extreme values. It only considers the extreme values. So limitation number 1, which you can note in your books, is that it considers only extreme values. considers only extreme values. And then number two, if we have two classes, let's say, let me construct class. This one was set A. If I also suppose that we have set B with the, let's say, 10, 13, 5, let's say 55 and 75. The range of A is 75 minus 5, which is 70. The range of B is again 75 minus 5, which is 70. Yet we have different figures in set A and set B. The figures are different because we have a 10 which is not here. We have a 13 which is not here. We have a 55 which is not here. So the range causes us problems that it does not distinguish between two sets with the same extreme values. So you can also write that one in your books. It does not distinguish between two sets, or you can say distributions, two distributions. A set is a distribution, two distributions with the same extreme values. So that makes it a problematic measure. One, we've said it only considers the extreme values. And then number two, it does not distinguish between two sets with the same extreme values. So if the highest score and the lowest score for set A and set B are the same, it will not distinguish between set A and set B. It will tell you that set A and set B are the same in terms of dispersion. They're the same in terms of dispersion. Next are the quartiles. Next, we shall jump into the quartiles. We have our quartiles here. The quartiles, they season out the limitations of the range by dividing data into, or dividing a distribution into 4 equal parts. The quartiles divide a distribution into 4 equal parts. And the quartiles are mainly 3. We have the upper one, Q3, which is the upper quartile. Then we have Q2, which is the semi-quartile, call it a semi-quartile or the median. It coincides with the median. That is our Q2, mid-quartile. And then we have the lower quartile, which is Q1. The lower quartile. Now, we usually don't talk about the mid-quartile because it is the median anyway, which we already know and have in our measures of location. The quartiles are used to compute what we call the what we call the interquartile range, sorry. They're used to calculate what we call the interquartile range, which is Q3 minus Q1. Which is Q3 minus Q1. Half of the interquartile range is what we call half of the interquartile range is what we call the semi-interquartile range, which is Q3 minus Q1 over 2. So this is the range by the quartiles. Okay, semi-interquartile range. So don't confuse the two. Semi-interquartile range is not the same as interquartile range. Semi is halfway. Semi is halfway of the interquartile range. Semi is halfway of the interquartile range. All right. Let us make use of June 2018 question 1 part B as our activity example to support the discussion on the quartiles. I'm going to give you some 2 minutes to take a picture, a screenshot. Yeah, you don't need to write because I'll share the slide is going to be shared on your student account under today's lecture. Yes, under today's lecture, you're going to see that we have the notes there. You look at the date of the lecture, and then you'll be able to access the slide. I usually put the slide and the solutions below the video or the recording of the lecture. So after watching, you just scroll a bit and check below the recorded Zoom lecture on your student account on this day. Like today is the 14th of May. So you just check below 14th of May lecture. You'll be able to download, the slide, which is a table showing weekly wages of 100 workers on a flower farm in Katunda village. You were required to study the table and answer the questions that follow. We have the weekly wage, the number of workers there, and we are going to compute the upper and the lower quartile. But before we do that, we need to appreciate the formula for calculating the upper quartile, Q3. And on your screen right now, I display the formula for determining the upper quartile over distribution. The formula, we have LU 3n over 4, CFU, FU, CW. LU is the lower boundary, class boundary of the upper quartile class. CFU is the cumulative frequency of a class before the upper quartile class. FU, frequency of the upper quartile class. N are the number of observations. CW, the class width for our distribution. So you're going to put down this formula in the next 2 minutes. Then I'll unmute. We go to the table computation. All right. So as you can see in the formula, everywhere we are talking about upper quartile class, upper quartile class, upper quartile class, and so on. So what does that one mean? It means that we need the upper quartile class. So we shall need this kind of table. I have already prepared the table for you because I know you are experts already. You know that this is the cumulative frequency, which is obtained by adding the successive frequencies like 10, 10 plus 16, 26, 26 plus 26, 52, 52 plus 28 is 80, 80 plus 10, that's 90, 90 plus 8, that's 98, 98 and 2, that's 100, which is supposed to be equal to the total frequencies. Then the class boundaries, I know you know, we subtract 0.5 from the lower class limit, add 0.5 to the upper class limit. So like 20 to 24, that's going to be 19.5 to 24.5, then 24.5 to 19.5, I mean 29.5, 29.5 to 34.5, 34.5 to 39, like that. Subtracting 0.5 and adding 0.5. Okay, so if we have this kind of information, we need the cumulative frequency, the cumulative frequency 3n over 4. That's 3 times 100 over 4, which is about how much? That's about how much? Anybody in the chat? That's about 75. So we look for the cumulative frequency that is very close. That should be greater, but closer to 75. And outrightly, that should be the 80. 80 is the one that is greater and immediately close to 75. So this becomes our Q3 class. So whatever, this becomes our upper quartile class. So what we need for our formula, remember our Q3 is saying we get the LU plus 3n over 4 minus cumulative frequency before, frequency within, times CW. So the LU is this one here, the lower class boundary of the Q3 class, that is 34.5. The N is 100, that's okay. Cumulative frequency before is the 52, cumulative frequency before. Then the frequency within is the 28. Class width, you tell me. So I want to substitute here. That's going to be 34.5 plus 3 times 100 over 4 minus 52 over 28. What is our class width? Just look at the difference here, 19.5 and 24.5. 24.5 and 29.5. What's the class width there? Class width. Anybody? Class width is 5. Okay. In the chat, someone is saying it is 5. So you can give me the upper quartile. You can give me the upper quartile. Okay. Maybe I first give you time to do the formula for lower quartile. I don't know whether there's anybody with a question on the upper quartile, because the submissions I've got, the upper quartile is 38.6. John Baptist, is 38.6 okay with you? Rachel, are we okay with 30? 38.6. Fred gave me a wrong figure, 149. I think you made an error. Faith, 38.6, yes. At least I saw an answer from Patience, an answer from Sam, an answer from Majib. So what do you think? 38.6 is okay? Good. So as I was saying, the lower quartile, we shall need to get the lower quartile class, which will be the class, the Q1 class, the class with the cumulative frequency close and greater than 25. Close and greater than 25. So you have the table. Just use your table there. First put on the formula. Use your table. Identify the lower quartile. Okay. Identify the lower quartile. Share with me your answers in the chat. All right, I can see some answers here. So I do believe you are, okay. Let me ask John Baptist to unmute and you tell us what you've done with your work there. John Baptist, unmute yourself.
Hope you get me well.
Yeah, can hear you properly. John Baptist. Yes.
I'm very grateful to be on this platform today.
Yeah, you're most welcome.
Yes.
So the formula, the Q1 is let me say LU plus N over 4 minus CFB over FW times CW. So what was your lower class? I mean, what was your lower quartile class? Which one did you take?
I took it was 29.5.
I mean, your class, the class, the lower quartile class. Which one? What did you use? 20 to 24, 25, 29, 30? Which one of these is the lower quartile class?
34.
30 to 34.
Yes.
Wow. Yet our cumulative frequency was what? Wasn't it 25?
Yes, 25.
So I think you took a wrong class because 25 would be in the 26 here. Because you are saying the lower quartile class should be the class with the cumulative frequency that is greater but very close. So this 26 is the one that is greater and close. So this one would be your Q1 class. Okay?
Yes.
So the frequency within is 16. Lower class boundary would be 24.5. So there you do get the 24.5 plus 100 over 4 minus the cumulative frequency before, which is 10, over the frequency within, which is 16, times the 5. So in it, is that where you're getting the 20 what? The 29.2 in it?
Yeah, that's where I was getting it. These formulas are very, they need some time to understand them. So for me, I'm not the first learner. Understand after reading.
It's okay. It's understandable.
Okay.
Understandable.
Yes.
So I was confirming with your colleague here in it. Can you confirm this is what you've done and you've got the 29? Okay, she says yes in the chat. Yes, that's what she has done. So the dollars, 29.2. That's the same answer that Majib has given me in the chat. Oh, who was removed? Someone had put the, okay. I think John Baptist, that's the same answer he has given me. A miracle, some kind of a miracle, miraculously. So that is miraculously, he has given us the answer there. Okay, 29.2. So those are the quartiles. But as I mentioned, that these quartiles, are used to determine the range, which you call the interquartile, the semi-interquartile range. So we can say that the, let me just use here. There are four, can say there are four. The interquartile range is equal to Q3 minus Q1, which is going to be 38.6 minus 29.2, which is about how many dollars are these? Anybody the calculator? $9.4. 9.4. Meaning that the semi interquartile range would be the 9.4 divided by 2, which is about how much? Anybody? Which is about 4.7. Good. 4.7. So that marks the end of our first segment. We are going to move into the second segment where I'm going to discuss the standard deviation. We are going to go into our second segment where I'm going to discuss the standard deviation. This recording, you'll find it on your student account. I've recorded the lecture, so you should be able to follow through. Later, if you want to refresh your mind regarding what we discussed today. So I'm going to give you some 2 minutes, put everything together, get ready for the standard deviation.